Okay, well, hi everybody. Today's lesson we're going to talk about is lenses. And there's a number of things that lenses do for us or lenses give us. So let's look at some basic information about them and how to use them and what their purposes are. So lenses. Almost everything in a lens is expressed in mm's, which is millimeters. Okay? Even something as simple as the lens cap, right, has information on the back side of it. You can't see it, it's really small, but this one says 77 millimeters. So that tells me that the diameter of the front of this lens is 77 millimeters. So if I wanted to get a filter for this lens, there are threads on the front. If I wanted to get a filter for this lens, I would indeed want to buy a 77 millimeter filter. Or if I lose my lens cap and I want to get a new lens cap, I would need a 77 millimeter lens cap. So for every lens, there'll be that information on the lens back inside of the lens cap. This one is 58 millimeters. And indeed, it's 58 millimeters diameter. Okay? So cool. The next thing about lenses is the size of the lens is expressed in millimeters, but it's expressed in what we call focal length. Now, a lot of you have these 18 to 55 millimeter lenses, especially on the school cameras, okay? Well, that doesn't mean that's how physically large or small the lens is. It simply refers to the focal length. Sometimes we refer to that as the magnification or the angle of view, right? So the smaller the number, say 20 millimeters, you have an 18 millimeter lens, is a pretty wide angle of view. Your 55 millimeter is a much narrower angle of view. So it has to do with kind of the angle of view and the magnification. Now, there's a number of things that lenses do for us. The primary reason for picking a certain millimeter or a certain lens is that controls, that's our view into our subject. So that's giving us our angle of view into our subject. So what works the best? Well, it depends on the situation. Now, the camera manufacturers aren't stupid, right? 18 to 55. Why would they use 18 to 55? Well, it's a good usable range. And at 55 millimeters, it's a nice range to use for doing portraits. It's a reasonable distance away, right? You don't want to be so close to somebody that it distorts the way their face looks, or it distorts how the scene is, right? And you don't want to be so far away and use a gigantic lens, right? Because then you're too far away. Okay. So a number of things to look at using lenses for and how they work and what they are best at, right? So here's two different lenses, right? This one's a 17 to 40 f4, okay? Now it'll say that right on the outside of the lens, right? Right around the outside of the barrel of the lens, it gives what specification the lens is, a 17 millimeter f4, okay? Now in this one, this doesn't say it on the outside of the lens, it says it on the front of the lens, right? And this one says this is a 24 to 105 f/3.5.5.6. Okay, so why two different f-stops? That's because as you zoom this lens out, it changes from a 3.5, so this is 24 to 105. At 24 millimeters, it's a 3.5. That's how big the aperture will open up. At 105 millimeters, or somewhere in the zoom range, it changes to a 5.6. Now, it will automatically do that, and your light meter will move because from 3.5 to 5.6, 3.5, 5.6 is getting smaller diameter, less light, So you will see your light meter go to minus or less light. Now a lot of you have the same lens, 18 to 55, and it will be a 3.5 maybe to a 4.5. So that means somewhere in your zoom range that is going to change, okay? So when we start looking at lenses and wonder why one costs a certain amount and another one that's very similar costs more. Well, this is what's called a variable aperture lens, and this one is what's called a constant aperture lens. So 17 to 40 f4. So this does not change throughout its zoom range. At 17 millimeters, it's an f4. At 40 millimeters, it's an f4, okay? Where this one changes, a lot of lenses change or have this variable aperture because it's less expensive to design and produce, and of course then it's less expensive for you to buy. So a constant aperture lens, like say, I have this, here's a 70 to 200, and it's a constant f2.8, 70 to 200 2.8. So it does not change the aperture throughout the zoom range, which is a really nice feature, but this is a pretty expensive lens. But now we can start to understand why things cost a little bit more as we look at what the features are of the lens, okay? Now here's another one. This one's mine. This is my 100 to 400, okay? And it is a push-pull zoom, right? This one changes. This is a variable aperture lens as well. And this one changes. It is a f4.5 to 5.6. So at 100 millimeters, it's an f4.5. At 400 millimeters, it's a 5.6. Okay, and I'm going to like this lens a lot. I like the push-pull. It's easy to operate, and it's pretty quick. So I'm pretty happy with that lens. Okay, so don't confuse the focal length of the lens with its physical size, right? Now this one has internal zoom. As you notice, as I zoom the lens doesn't extend or change. You notice as I zoom this lens, the lens physically changes size as the lens barrel extends out. Okay, let's do a comparison then. You notice on this 70 to 200 I have here, as I change the zoom, right, nothing happens. The lens does not physically change size. The zooming happens internally in the lens, okay? A little more expensive. Now, this one zooms externally, okay? It's very important that this lens never gets hit from the side, okay? It'll take an impact straight on, but you never want to get this lens hit from the side. So you want to be very careful handling a lens that extends like this, because the bearings and slides that keep these glass elements perfectly parallel can get damaged. And when they get damaged, the lens can wobble or move a little bit, and that will contribute to lack of sharpness in the lens. So very important that the glass elements in the lens stay perfectly parallel. And when this is extended, this cannot move, okay? So it's very important that if you have a lens that extends like that, that you're very careful with it, especially when it's extended all the way, okay? So a little bit about taking care of your lens a little bit. Okay. So what do lenses do? Well, lenses give us our angle of view into our subject, okay? So we talk about a wide-angle lens gives us a wide angle of view. A more telephoto lens gives us a narrower angle of view into the subject. Well, what does that do to our subject? Okay, so it does a number of things to our subject. And the main thing is, that changes our perspective. And that's the big deal with lenses. It changes our perspective. Okay, a wide-angle lens tends to expand the relationship between objects. It broadens it out. A more telephoto lens, a big lens, 100 millimeters, 200 millimeters, 300, 400 millimeters, right, will compress the space between objects. So, big lens compresses, wide angle lens expands. So this becomes really fun or interesting to play with. And again, like I said before, the camera manufacturers aren't dumb. Why did they pick 18 to 55 for your lens, or for a kind of a basic kit lens? Or why this one, a 24 to 105 for the kit lens for this camera, right? Because they have a usable zoom range that makes it easy to utilize the lens. All right. Well, we have to now talk about other aspects of what's going on with your lens, and specifically what's going on with your camera, okay? Because there's a big deal here that changes as we start to look at what kind of camera you are using, okay? There are two, basically. There are a few more, but we're basically going to talk about two. There is FF, which stands for full frame, and there's crop, which stands for a crop sensor. Okay? Full frame is the same size as a piece of 35 millimeter film. Okay? A crop sensor is smaller. Oh, doesn't want to work because of the... A crop sensor is a smaller sensor size. Okay? Now, what does that have an effect? Well, this has an X factor, and it's 1.6 on Canon, and it's 1.5 on Nikon or Sony. So what does that mean? That means if you had a 100 millimeter lens on a full frame camera, it's a 100 millimeter lens. If you have a 100 millimeter lens on a crop sensor camera, you must apply the X factor. So that is actually a 160 millimeter lens. Okay. Well, this starts to get deep here very quickly. Because if you remember, I'm sure you do, what are the three components that contribute to or control depth of field, right? DOF. Well, one of them we know is fstop, right? Right? One is fstop. That's 1, 2, 3. The other one is distance, right? How close you are to your subject. What's the third one? Obviously what I'm talking about, millimeter of lens. Okay? So, depth of field, a contributing factor to depth of field is millimeter of lens. So a 100, 200, 300 millimeter lens, your depth of field shrinks for the same f-stop. A 50, 40, 30 millimeter lens, your depth of field increases for the same f-stop. So now you're shooting a crop sensor camera and you have a 100 millimeter lens. That lens is really a 160. So you had a depth of field problem and you didn't know it, right? So that's one of the problems of especially working indoors with crop sensor cameras, is that the lens is actually magnified by that 1.6 or 1.5 X factor. And the easiest way to do this is just to show it to you. So in my left hand here, this is a full frame camera. This is a 6D Mark II. And this is an 80D, a crop sensor camera. So I'll get in here tight, and hopefully you can see into the camera a little bit and see the size of the mirror, right? See the size of the mirror in there. The one is pretty good size, the other one's pretty small. Okay, hard to get the light in there, okay? So you can see that these two are different. The sensor size is different, the actual physical size of the sensor, not the megapixel count. Okay? You can have high megapixel count cameras that are crop sensor. Okay? You can have high or low megapixel count cameras that are full frame sensor. Okay? So what happens with that essentially is that smaller sensor essentially magnifies, or X multiplies, the millimeter of the lens. So you get X factor. Okay, so what does that mean? Well, you all know just by simply looking through your camera what you see. I'm not telling you anything you don't know. The issue is that you have an 18 to 55 millimeter lens, right? On your crop sensor camera. Is that really an 18 to 55? Well, now you know. Of course, the answer is no. It is not, right? 18 times 1.6, right? We have to do the multiplication factor. 6 times 8 is 48, right? So if we multiply that, right? So it's really what? A 37 millimeter, 6 times 48, so 38 millimeter. 6 times 5 is 30, so is it really 88? So it's really 38 to 88. Did I do the math right? I'll have to check it and make sure. Right? So that lens, if you were to put that, able to put that lens on a full frame camera, it would be an 18 to 55. But with the X factor on the crop sensor camera, it's really like a 38 to 88. Now, again, the camera manufacturers aren't dumb. Why did they pick that zoom range? Because 38 millimeters is kind of wide. It's a nice angle of view. My favorite lens on a film camera back in the day was a 35 millimeter lens. And 88, one of the ideal portrait lenses, is around 80, 90, or 100 millimeters because it renders the relationship between everything accurately. So we start thinking about why do we have these lenses and what are we doing with them and what do they do for us, right? We start to look at, we have to understand crop factor a little bit and understand what camera you have and what lens you have and what it's really doing for you, okay? Now, a couple of fun things as far as lenses go, right? I didn't bring one back from school, so this is mine from before. So this is a 50 millimeter lens from my old film camera, okay? Regular 50 millimeter lens. This is what's called an extension tube. And it's simply a piece of metal that allows me to extend the lens out from the camera body, okay? That's all it does. So this would attach, actually I have the camera right here. Right? So here's that 35 millimeter lens that was my favorite one years ago. This is my old film camera, my old Canon F1. Okay? So normally this lens would simply just fit on the camera, right? 50 millimeter. But let's say you wanted to do some close-up pictures or some macro pictures. Well, you can put the extension tube on your camera body first, and then you put the lens on. Get on there. There we go. There we go. Now that extends the lens out from the camera body, thus magnifying or essentially giving it a much closer focusing distance. So I'm now able to turn my 50 millimeter lens into essentially a macro lens. Very popular, very easy thing to do. Doesn't weigh much, right? For something to have in your camera bag. Not terribly expensive, so that if you want to have a more macro type lens, you simply can buy an extension tube. Okay, so those work really well. The other thing you can do is that there are little filters that will fit over the lens, just like when you go to the Rite Aid or whatever, any of the pharmacy stores or even Walmart or whatever. You can get reading glasses, and they're labeled in like plus 0.5, plus 1, plus 2, plus 3, whatever. They're magnifying lenses for reading, right? You can get the same thing for your camera lens, right? And you screw those onto the front. That's why it's important to know your millimeter size of your front element of your lens. You screw those onto the front, and those plus lenses, they're called, or macro adapters that go on the front lenses, they screw right on. And they usually come in plus 1, plus 2, plus 3, and that will also take your 50 millimeter lens and turn it into a macro lens. Very handy feature as well to have in your camera bag, a plus lens or a plus filter or plus 1 or 2 of them, or a extension tube, okay? A couple other things that we can do with lenses. Now, again, I didn't bring one of these home, but you can get an extender or a multiplier that fits onto certain lenses that will multiply the lens and increase its focal length, okay? So if you had say you had a 100 millimeter lens, right? And you used a 2x multiplier, you'd have a 200 millimeter lens. So that's pretty cool. You can buy, they're called teleconverters. And they usually come in 1.4 or 2x, and they will multiply the focal length of your lens. Now that's pretty cool because they're small, lightweight, not terribly expensive, and they multiply the usage of their lens. Now they don't fit on every lens, that's the problem. They're only designed for certain lenses. And they absorb light. A 1.4 teleconverter absorbs 1 stop of light. A 2 times teleconverter, you got it, absorbs 2 stops of light. So they do have some drawbacks, but they do have a lot of benefits to them. I carried a 2 times multiplier with me for 30 years. They're incredibly handy to have, and they will get you out of a situation or allow you to take a certain picture that you want, even if you don't have the lens with you, okay? I carried this 35 millimeter lens with me. I carried a straight 200 millimeter lens and a 2 times converter when I was going out on a job, and I had very little that I could carry with me. That's all I could carry. That was my typical carry setup. That gave me a lot of flexibility in terms of being able to shoot with a variety of lenses. Then I had a 400 millimeter lens with me that just had a 200 millimeter lens and a 2 times converter, so very handy to have. Okay, so that's a little bit about lenses. We'll finish this up, and I'll do another video in a couple minutes here and get that one out, and we'll talk about what your assignment is for lenses and perspective. Okay? See ya.